Okay, everyone, assalamu alaikum. Let's begin. So we were doing kinematics, and in today's class, we will be discussing graphs of kinematics functions. That's the plan for today. And along with that, we will be doing any practice, any questions that you have from the worksheet or otherwise as well. So after today, you should be able to do all the questions from the first two rows of the assigned questions. Okay. Now, before we do any practice questions today, I want to start with graphs first of all. So what have we done until now? In the last couple of classes, we have talked about these constant acceleration formulas. Now, sometimes they will tell you in the question that acceleration is constant. If they don't tell you, we said the general rule is whenever all the forces acting on an object, they are constant, then acceleration is also constant. So sometimes they don't specifically mention that in the question that acceleration is constant. You would be using this rule for that. There's two specific examples, two specific cases of this rule where this rule applies. That is free fall, and when you have a smooth inclined surface where weight is the only force. So both of them then can be classified under motion and gravity. So in free fall, you have an object moving in the vertical direction, upwards or downwards under gravity. In that case, acceleration in the downward direction is 10 meters per second square. And depending on which direction you're taking positive, if you take upwards positive, the value of acceleration would be minus 10. If you're taking downwards positive in some case, in that case, acceleration would be positive 10. Then we talked about the smooth inclined surface case, in which we have a smooth surface inclined at an angle theta, where there's the only force acting is the weight of the object. We say the acceleration is given by 10 sine theta, where theta is the angle of inclination of the plane. And then we discussed how to choose which direction to take positive. This is a very important thing in kinematics. Otherwise, you'll end up doing a lot of careless errors if you're not careful about it. How do you choose which direction to take positive? Now, theoretically, we said you could actually take any direction as positive as long as you're consistent. It would work. However, going with these conventions is going to make things simpler to understand and more intuitive. So what's the convention that we'll be using? We'll be saying, if the object is moving in only one direction, you just take that direction as positive. Okay. If the object is moving in only one direction, just take that direction as positive. However, if the object is changing direction during motion, if it can change direction during motion, generally what we do is we take upwards as positive if it's vertical motion, and right side is positive if it's horizontal motion. Okay. However, keep in mind, if it's two-way motion, it does not mean when the object is going in one direction to take that as positive and then change that when the object changes direction. Don't do that. For each object, keep one direction positive throughout motion. Do not change the positive directions during motion. That's going to complicate things a lot and almost always result in careless errors. So keep the same direction positive throughout the motion for every single object. Okay, for each object separately. We did one question from the worksheet as well. That was question number 9. And I asked you to attempt the other questions from the worksheet after that. Now, I understand you would have some problems from the worksheet. If you have attempted questions, we will be discussing those problems. But first of all, I want to start with graphs today so that you have 3 days after that to attempt more questions. And then we can discuss any problems that you have on Wednesday, on Tuesday, inshallah. Kinematics graphs. So let's start with this today. First of all, there are 3 main sections of this kinematics topic, 3 different major concepts on which they ask questions. One is when acceleration is constant. We have talked about that before. The other type of question is in which you have some graphs involved. And then the third type is where you have some equation given in the question for acceleration or velocity, and acceleration is not constant. We're just going to discuss the second type where you have some graphs of kinematics functions. Now, there are 2 types of graphs that you have in your syllabus. Number 1 is displacement time graph. That's the first type of graph. displacement time graph, and the second one is velocity time graph. These are the two graphs that you have in your syllabus. Okay. Now, if you have a displacement time graph, if you have a displacement time graph, what that means is displacement is on the vertical axis and time is on the horizontal axis, right? So time will always be on the horizontal axis because that's an independent quantity. Displacement depends on time, so that's on the vertical axis. Whenever you have a displacement time graph, the gradient of this graph is going to represent velocity. Why? Because how is velocity defined? Velocity is defined as the rate of change of displacement. At what rate is displacement changing? If you have displacement on the vertical axis and time on the horizontal axis, and you have a function that looks like this, the gradient is going to tell you every second how much is the displacement changing. And that's exactly what the definition of velocity is, right? Rate of change of displacement, that's velocity. So gradient of a displacement time graph gives you velocity. And the second thing is the area under graph. The area under graph, that is going to give you, that's actually not going to give you anything. So gradient gives you velocity, area under this graph does not give you anything. Let me actually write that here as well. Area under graph gives you nothing here. Okay. Now, I'm writing this because area under graph for the second type of function, for the second type of graph does give us something. So for displacement time graph, area under graph does not give you anything. Now, what about velocity time graph? In the velocity time graph, we have velocity on the vertical axis and time on the horizontal axis, right? So what about the gradient? What is the gradient going to represent here? Gradient is going to represent rate of change of velocity. How much is velocity changing? Every second. Rate of change of velocity. What's that? That's the definition of acceleration. How much does velocity change every second? So gradient of the velocity time graph is going to give you acceleration. And the area under graph for a velocity time graph, that is going to give you displacement. Because if you have a graph like this, for instance, this is time, this is velocity. If you have a graph like this area, how do you find this area? If it's a rectangle like this, you find this area by doing length into width. What's length? T. What's width? V. V into T. What's velocity time? Velocity into time. That's displacement. So if it was some other graph as well, curve or an inclined or an upward sloping line or a downward sloping line, the area under the graph, that's going to represent displacement. So for these two graphs, this is what you need to remember. For a displacement time graph, the gradient represents velocity. For a velocity time graph, gradient represents acceleration, and the area under graph represents displacement. Now, this is how you can kind of remember this. You have three quantities that you are primarily dealing with here. One is displacement. One is displacement. And then you have velocity. And you have acceleration. For the displacement time graph, if you were to find the gradient, you would get velocity. For a velocity time graph, if you were to find gradient, you will get acceleration. All right. So as you go from left to right, you're finding gradients. Displacement time graph, the gradient of that is going to give you velocity. Gradient of velocity time graph is going to give you acceleration. And then if you have velocity time graph, area under that graph is going to give you displacement. And if you had acceleration time graph, although that's not part of your syllabus, but if you had it, the area under graph for acceleration time graph, that would have given you velocity. But this is not in syllabus because acceleration time graph is not in syllabus. So we will only be dealing with displacement time graph and velocity time graph. So for a displacement time graph, gradient gives you velocity, area under graph does not give you anything. For a velocity time graph, area under graph represents velocity and the gradient represents acceleration. Okay. That's pretty much all that you need to know about this. Now, let's try to understand how to describe one particular displacement time graph, for instance, how to understand different parts of a displacement time graph and how to understand different parts of a velocity time graph using a couple of examples. So I'll just leave it here for a few seconds in case you want to note anything now.
Sir,
Yes, Abdullah.
sir, yeah, are you multiplying time with displacement to find gradient? So basically to find velocity, or are you dividing it?
Where exactly?
Sir, in the graph, in not in the graph, in the diagram that you have drawn.
We're not doing anything. It's just to represent. I'm not multiplying or dividing anything. I'm just saying displacement time graph, the gradient of that is going to give you velocity. The gradient of velocity time graph is going to give you acceleration. The gradient of area under graph or velocity time graph is going to give you displacement. We're not talking about division or multiplication here. We're talking about gradient and area under graph. So if you find gradient of displacement time graph, you get velocity. If you find gradient of velocity time graph, you get acceleration. And if you have to go backwards, you find area under graph.
Okay, sir.
That's just a representation to kind of remember this. This is the actual thing. How the gradients and areas on the graph are related. Okay, just give me a minute. I'm disconnecting my charger. All right. So we have this displacement time graph and velocity time graph now. Now, let's try to understand how to interpret different sections of these graphs. Let's start with the displacement time graph first of all. Let's say we have a graph that looks like this. This is displacement on the vertical axis, time on the horizontal axis. That's how it's always going to be. Time is always going to be on the horizontal axis. And of course, you're not going to have anything on the negative side of time. Right? Displacement and velocity can be negative, but time cannot be negative, of course. Let's say you have a graph that looks like this. You're going in this direction, and then let's say you go maybe right like this, then you come down as a curve. Then you could have maybe a line like this. And let's go back. to the same point. Okay, so let's say we have a displacement time graph that looks like this. Okay, so this is as complicated as it generally gets, as in we have curves in some part, we have lines in some part. Sometimes it does get a bit complicated, but mostly it's going to look something like this. Now, how do you understand the journey of this object? It's starting from origin. Let's call these points something. Let's say this point is A, this is B, this is C, this is D, and then you have E. We want to understand what is happening in each of these different parts of the graph. It's a displacement time graph, right? So we want to understand what's happening to velocity, what's happening to acceleration, what's happening to displacement in each of these different parts on this graph. Okay. So this is what the graph looks like. I'm going to write down here the different sections that we have in the graph. We have section OA, then we have AB, BC, CD, DE. These are the 5 different sections that we have on the graph, right? Let's understand how displacement, velocity, and acceleration are changing in each of these parts. Displacement, velocity, and acceleration. What can you say about each of these things using this diagram? Okay, so displacement is actually represented on the vertical axis here. So displacement can just be read from whatever is happening to the vertical axis. What about velocity? Velocity is the gradient of this graph, remember? Displacement time graph gradient gives you velocity. Now, keeping that in mind, can we say what's happening to displacement from O to A? From O to A, what is happening to displacement?
Displacement is increasing.
It's increasing, right? So in increasing, decreasing, we just talk about it from that perspective. Is displacement increasing or decreasing? It's increasing. From point O, you're going to this point A in the positive direction. So let's say you have a point O, let's also represent what the journey might look like. Let's say it's the particle is moving horizontally. Assuming that we're saying the right side is positive, how would this journey look like? The particle is first going to go towards the right side in the positive direction, right? Let's say this point is A. So it goes to the right side like this. Okay, that's what's happening in the first part. Then, what about velocity in this part? What's happening to velocity? Is velocity
increasing.
changing? Is velocity increasing?
Constant.
Velocity is constant. Velocity is represented by the gradient of the graph, right? Gradient of this graph is constant. It's a straight line, right? The gradient is constant. Since the gradient is constant, we say velocity is also constant. The object is moving at constant velocity in this part of the journey. And that's a positive constant value. So velocity has a positive value because the gradient is positive, but it's constant. It's not changing. All right. What about acceleration? What's happened to acceleration?
Zero acceleration because the velocity is constant.
If the velocity is constant, acceleration is going to be 0 because acceleration is defined as rate of change of velocity. So acceleration is going to be 0. Okay, that's what's happening from O to A. So from O to A, the object is moving at constant velocity. Its displacement is increasing. Acceleration is therefore 0. What about A to B? A to B, what's happening to displacement?
It remains till there's no increase in displacement.
There's no change in displacement, right? So displacement basically remains the same. So you can say displacement remains constant. So you can say it's at rest. Displacement is unchanged. The particle is at rest, and the displacement is unchanged. There's no change in displacement from A to B. If there's no change in displacement, what about velocity? That means velocity is zero. The object is not moving. What about acceleration? Acceleration is also zero. If the velocity remains at zero, acceleration is also going to be zero. Okay. What about the part BC? What's happening from B to C?
Displacement is reducing.
Displacement is decreasing, and the particle is coming back to the original point where it started, right? Because displacement becomes zero eventually. So displacement is decreasing. From O to A, the particle was going to the right side. A and B are basically the same points, right? Because it remains at rest. And then it starts coming back. It comes back to point O. So O and C are also the same point, right? C is the same point as O. It comes back to the same point like that. If the displacement is decreasing here, what about velocity? What's happening to velocity?
Sir, from
Yes.
B to C, isn't displacement going to be zero at it came to its starting point at C?
Yeah, so displacement is decreasing from a positive value. So it was some number here. Let's say it was 5. So displacement going from 5 to 0. So it's decreasing from 5 to 0. Eventually it becomes 0, yes. But from B to C, that interval, it's decreasing.
Okay, sir.
Okay. What about velocity? What's happening to velocity?
Velocity is increasing, but in the negative direction.
Velocity is increasing, but in the negative direction. So how would you say that? Velocity is increasing or decreasing? Remember, velocity is a vector quantity. So if we are saying the right side is positive, what do we say about velocity? Velocity is going to be decreasing, right? So that's a rather confusing way of saying that. Velocity is increasing in a negative direction. You can say that. That's perfectly okay. But instead, it will be easier to interpret it like this, that the velocity is going from 0. It was 0 at the point B. And then from 0, it's going to a negative value, right? So it's actually decreasing. Velocity is decreasing. If you look at the actual value, what's happening to the actual value? The value is decreasing. The value is decreasing from 0 to negative. Why is that important? Because if we understand it correctly, that velocity is decreasing here, that clearly tells us that the acceleration is now going to be negative in this case because velocity is decreasing. From B to C, remember, gradient of the graph represents velocity. What was the gradient initially? It was 0 here at B, and then it became negative, and then became more negative. It keeps getting more and more negative. So it's starting from 0, and then it's becoming negative. So when it goes from 0 to a negative value, we can say, mathematically speaking, the velocity is decreasing. Make sense?
Yes, sir.
Speed is increasing, but velocity is decreasing because it's in the negative direction. And since the velocity is decreasing, we say acceleration is going to be negative because acceleration is rate of change of velocity. If velocity decreases, acceleration is going to be negative. There's going to be deceleration in this part. Again, mathematically speaking, because velocity is decreasing. Okay. Now, what about C to D? What's happening in this part? Now we have displacement increasing or decreasing.
Decreasing.
Displacement is
Decreasing.
increasing or decreasing? Decreasing. Again, considering the positive direction, now the particle is going from this point C to some point on the left side. Now it's moving to the left side. Now, since it's going to the left side, we can say, sorry, it's going to this point here. This point is D. the displacement is becoming negative from zero. So it started from zero. From zero, it's going to a negative value. So it's decreasing. Displacement is decreasing in this part as well. It's going from zero to a negative value. So you need to make sure that you understand the positive and negative directions correctly here. Since it's going to the negative side, we say displacement is decreasing, even though its distance from the starting point is increasing, but it's increasing in the negative direction. That's why we say it's decreasing like this. What about velocity? Velocity is constant gradient.
Constant in the negative direction.
Yeah, so it's constant and it has a negative value, right? It's constant and it has a negative value. And what about acceleration?
Zero.
Zero. If the gradient is constant, if the velocity is constant, there's no acceleration. Acceleration is going to be zero. And then the last part, dE, what's happening in that part? What about displacement?
Increasing.
It's increasing, right? How is it increasing?
Sir,
It's
it's going
going
to
from,
positive gradient.
no, gradient
Positive
does not have
axis.
anything to do with
Not gradient,
it.
positive axis.
Yeah, so from negative, it's becoming zero. It was initially a negative value, right? And then from negative value, it's going to zero. That means it's increasing. On that diagram, if point D is here, what does the particle do after point D? After point D, it goes back to the origin again. It goes back to this point. This point E is the same as the origin as well. It comes back to the same point again. Now, if displacement is increasing in that part, what about velocity? Can you see what's happening to velocity in this part?
It's increasing.
Velocity is increasing. How do we know that?
Sir, through the shape of curve.
The gradient is increasing. Yeah. So gradient is increasing in this part.
Sir, we can
It
say
was,
that it's getting steeper.
yeah, it's getting steeper. That's what it means for the gradient to increase. This is less steep here. This is more steep, more steep. So in the positive direction, it's getting more steeper. The gradient is increasing. Since the gradient is increasing, that means the velocity is increasing. What about acceleration? Can we say anything about acceleration? If the velocity is increasing, acceleration
Sir,
is supposed to be
increasing. Positive.
it's a positive value. We can't say whether it's increasing or decreasing. From this
Yes.
graph, we can't really say anything about acceleration, about whether it's increasing or decreasing. We can just say whether it's positive or negative, right? It really depends on what this curve actually corresponds to, which function it is. It could be constant, it could be increasing, it could be decreasing. All we know is that it's some positive value, right? When velocity is increasing, the acceleration is some positive value. Make sense? So that's how you would interpret different sections of this displacement time graph. Any problem with this?
No, sir.
No? Now, velocity time graph is something that you will be dealing with a lot more, because in that case, you can also find the area under graph to find displacement, for instance. So that is something that you'll find being used more. Let's talk about that as well. Velocity time graph. Again, we could take an example like this of a velocity time graph as well. Let me draw a graph here like this. So we have velocity on the vertical axis and we have time on the horizontal axis. Let's say the graph looks something like this. So the particle goes here, and then it goes horizontal. The graph becomes horizontal. And then let's say it goes like this, and then maybe like let's say like this. Okay. So this is what the journey of this particle looks like. Okay, the velocity time graph. That's what the graph looks like. Let's try to understand different parts of this graph as well now. So it's starting from origin. Let's say this point is A, and we have this point that's this point is O, and then we have A, and then B, and then we have C and D, and we have E. Again, let's try to understand what's happening in each of these different parts on the graph. OA, AB, BC, CD, and CE, DE, sorry. Let me just copy all of this. Okay, so these are different parts of the graph. We want to understand what's happening to displacement, velocity, and acceleration, each of these different parts. Now, it's a velocity time graph. In a velocity time graph, displacement is the area under the graph, and acceleration is the gradient of the graph. So keep that in mind while you try to interpret this. Area under the graph represents displacement, and gradient of the graph represents acceleration. Now, what's happening from O to A? O to A. What's happening in this part of the graph? What's happening to displacement, first of all? In fact, let's start with velocity because it's a velocity time graph. So let's start with velocity first. What's happening to velocity? Velocity is increasing.
Decrease.
It's going
Increasing.
It's going to a positive value, right? So it started from 0. It's going to a positive value. So it's going from 0 to a positive value. So velocity is increasing. Okay. Velocity is increasing. What about displacement? Where does displacement come from? On this graph, displacement is the area under the graph, right? What's happening to the area under the graph from O to A? It's increasing. This is the area under the graph. It's increasing at every single point. So initially it would be like this area, and then there's more area, then there's more area. So the area under the graph is increasing as we go from left to right. So what's happening to displacement then? This is also increasing. What about acceleration? What's happening to acceleration in this part?
Increasing because the gradient is positive.
Think again. What's happening from O to A to acceleration? It's a velocity time graph, remember? What does the gradient of a velocity time graph represent?
Acceleration.
Gradient represents acceleration. What's happening to the gradient in this part of the graph from O to A? It's steep earlier, and then it becomes less and less steep. So the gradient is decreasing. If the gradient of the graph is decreasing, that means acceleration is also decreasing. It's a positive value, yes, but it's decreasing, right? It's more positive initially, but then gradually acceleration keeps getting less and less. All right?
Yes, sir.
That's the first part. Now from A to B, is the particle at rest from A to B?
No, because it still has some velocity, but it's constant.
Yes. So in a displacement time graph, if you have a horizontal line like this, that represents that the particle is at rest. But in a velocity time graph, when you have a straight line like this, horizontal line like this, that means the velocity is constant. The velocity is some constant positive value. If velocity is constant, what's happening to displacement? Displacement is increasing as well, right? So area under the graph is increasing. So we say displacement here is increasing. Okay. What about acceleration? If the velocity is constant, acceleration is going to be 0. Okay. Make sense?
Yes, sir.
What about BC? What's happening from B to C? Velocity is going from positive to 0. So velocity value is decreasing. Okay, velocity value is decreasing. What about displacement? What's happening to displacement? From
It's
B to C.
increasing.
Velocity is decreasing. Is the displacement still increasing?
Yes, because
Yes, sir.
Yes.
because the area is still above the x-axis.
Area still above the x-axis. We still have this area being added, right? So it's like a car that's applying brakes, but it's still moving in the forward direction, right? So the velocity is reducing, but it's still moving. So it still has this displacement being covered. So displacement is still increasing in this part of the journey. What about acceleration?
And that's decreasing.
Negative.
It's a negative value, yes, but is it decreasing? It's a straight line. B to C is a straight line. Gradient of this line is constant. That means the acceleration is also constant. Okay, this understanding is really important. Now, in every question, you might just need to use one or two of these things, but once you understand all of these well, then you would not be confused about what's happening in each of those different graphs. So in this case, from B to C part, the acceleration value is constant, right? Because it's a straight line. Gradient of this graph represents acceleration. If the gradient is constant, that means acceleration is constant. Now, but then since this gradient is negative, we say it's a negative value, but it's constant. Make sense?
Yes, sir.
Then what about CD? What's happening to displacement here from C to D?
Decreasing.
So constant.
Okay, so let's actually start from velocity. Velocity is decreasing. It's going from 0 to a negative value. You can write that here first. Velocity is decreasing. It's going from 0 to a negative value. What about displacement? This area is being added. However, this is area below the graph. This will be negative displacement. So displacement is going to start decreasing at this point. Remember, on we also talked about this. Velocity is what tells you the direction of motion. So in this part of the graph, where the graph is above the x-axis, above the horizontal axis, the particle is moving in one direction, the positive direction. And then when the graph goes below the x-axis, below the horizontal axis, the particle starts moving in the opposite direction. So the particle is going to look like this. As the journey of the particle is going to look like this, it goes from O to C to the right side. You might have some point A here and another point B here, then another point C. And then at C, it starts moving in the backwards direction. So it starts coming back. There will be some point D here, maybe. And then it comes back more to some point E. This is what the journey looks like here. So from C to D, you can see the displacement is decreasing. Displacement from the origin. Displacement from origin, again keeping the right side as positive. At C, the displacement was more. When the particle comes to D, the displacement is decreasing. So this is decreasing. What about acceleration? Acceleration is constant at a negative value because the gradient is constant. All right. Think about D. I'll take a 1-minute break for Azan. Let me know what's happening in DE part in the chat box. Okay, let's look at this part now. DE part of the graph. So what's happening in this part? Okay, DE part, displacement is going from negative to 0, right? It's going from negative to 0. That means it's increasing, right? It's going from, okay, I'm sorry. It's a velocity time graph. I got distracted. Velocity is going from negative to 0. So velocity is increasing. It's going from a negative value to 0. What's happening to displacement? You see there's negative displacement adding there. So displacement is actually decreasing. It's going from point D to point E. Distance from origin is decreasing. So displacement is decreasing in this part because there's more negative area being added. So there's more area being subtracted here. So displacement is decreasing. And this part as well, because the particle is moving in the negative direction. What about acceleration? It was positive, but it's gradually decreasing, right? From a high value, it's becoming lower and lower. So we say the gradient is decreasing. Acceleration is decreasing. It's positive, but it's more positive initially, and then it gradually decreases like this. Okay? Does all of this make sense to everyone? Any problem with this? So you need to understand the different parts of a motion like this. Let me know if there are any confusions. So using the graph, you should be able to figure out the direction of motion like this as well. Like we figured out here, the object is first going from O to C in the right direction, and then from at C, it changes direction when velocity value becomes 0. You see, when velocity becomes 0, the particle is changing its direction. That's also another important thing to remember. Whenever an object changes direction, generally what happens is the velocity becomes 0 at that point. So when velocity becomes 0 at point C, the object is changing its direction. Any questions on this? No?
No, sir.
So now you should be able to do graph questions as well. Now, those of you who have attempted questions, let me know if you have any graph question that you want to ask. We could probably start from that. If you have already attempted any graph questions as well, or is that I'm being too optimistic?
So there was only one graph question among the first row, and it was fairly simple. That they were only asking for the area under the graph in it, so I had no problem with that. But I had problems with other questions. One was question 74, and the other one was question 24.
Yeah, we will be doing them in the next class, inshallah.
Okay,
The other questions that you have, I want to do a graph question quickly because that's what we've discussed now. So on Tuesday, we will just be doing practice questions, okay?
okay, sir.
But if anyone has any graph questions, you can let me know right now. Otherwise, we are going to. So I'm going to just take one question myself then from the worksheet. Let's discuss that. By the way, there are some questions in which there's some time delay involved. Please try that for the next class as well. Just quickly have a look. Yeah, question number 27 in particular. Question number 27. I expect you to do all the assigned questions before the next class, the first 2 rows. But if you are not able to do all of them, 27 should definitely be done along with the other questions, okay? So if you miss any of the first 2 rows of questions, don't miss 27. 27 you should have done before the next class. Okay. All right, let's have a look at a graph question. A relatively simpler one, maybe. Okay, let's try this one. Question number 4 from the worksheet. Okay, let's just try this question before we end today. So we have this displacement time graph given for a car's journey. The graph consists of two curved parts, A, B, and C, D. You can see that. There's one part here and another part here. And a straight line BC. The line BC is a tangent to the curve AB at B. Okay, so BC is a tangent to the curve AB at this point. That means the straight line has the same gradient as the gradient of the curve at this point. Okay, that's what it means. If it's tangent to the curve at A, curve at the point B, that means the gradient of this line is the same as the gradient of the curve at the point B. Okay, because tangent and a curve have the same gradient at a particular point. Okay. Now, what about the curve CD? This line is also a tangent to the curve CD at the point C. That means the gradient of the curve at that point C is also the same. Okay. Now, that's what we're given. The gradients of the curves at t equals 0 and t equals 600 is 0 at t equals 0 and 600. Okay, so initial gradient is 0 and the final gradient is also 0. The acceleration of the car is constant for time between 0 and 80. So acceleration is constant for time between 0 and 80 and also 5, 6 to 6 minutes. So in the curved parts, acceleration value is constant. Okay. And displacement of car is 400 meters when time equals 80. So in the first 80 seconds, the car covers 400 meters, as you can see here. That's the information that we're given. In the first part, they ask us to sketch the velocity time graph for the journey. Using this displacement time graph, we have to sketch a velocity time graph. Now, let's try this. You're going to keep this displacement time graph in front of you and use that to sketch the corresponding velocity time graph. Part 1. This is the displacement time graph. Let's draw the corresponding velocity time graph. Okay, so you have time on the x-axis and you have velocity on the vertical axis. Now, what are the important time instances? You have 0 when the object is starting, and you have 80 seconds, and then you have 560 at the end, and 600. These are the important time instances. Now, what are the velocities at each of these points? Let's first represent them. So it says, remember, it's a displacement time graph. The gradient of a displacement time graph represents what? Velocity. So whenever they're talking about gradient here, they're talking about velocity. So velocity at time 0, what's that? That's 0. So this graph is going to start from 0, like this. Okay, that's one point that we have. The gradient of the curve at both of these points is 0. At time equals 0 is also 0. That means velocity at time 0 is 0, and velocity at time 600 is also 0. So this velocity at the end is also going to be 0. So that's another point that we have. All right. What else are we given? The acceleration of the car is constant for time between 0 and 80. And for time between 560 and 600, what does that mean? What do you understand from that? Acceleration is constant. What do you understand for the velocity time graph if acceleration is constant?
The velocity is also constant.
If acceleration is constant, does that mean velocity is constant?
The
So
gradient
it
will be
is
constant, so
increasing at a
velocity will be a
constant rate.
straight line.
Gradient of the graph is going to be constant. Velocity time graph's gradient represents acceleration. If acceleration is constant, that means the gradient of the graph of the velocity time graph is constant. Okay, so from 0 to 80 seconds, the car reaches some velocity. We don't know what that velocity is. Let's say that's this point here. This line is going to be constant. It's going to be a straight line because the gradient is constant. That's what we understand from this. Okay, and then from this point to this point, from B to C, it's moving at constant velocity because the gradient of the displacement time graph is constant. So this part on the velocity time graph is going to be horizontal because the velocity is constant up to 560. And then it goes from 560 to 600 like this. That is what the velocity time graph is going to look like in this case. Does that make sense?
So why is the velocity 0 at the end? It's the gradient is decreasing, but
It tells us in the question. It tells us that the gradient of the curve at t equals 0 and t equals 600, that's 0.
Okay. Okay, sir.
Right? So that means if the gradient of the displacement time graph is 0, that means the velocity is 0.
Sir, why is the acceleration not 0 from B to C?
From B to C, because from B to C, acceleration is 0. It is 0. Because the gradient of this graph is 0. So acceleration is 0, yes. From B to C. Is that okay?
Yes, sir.
Now it says find the velocity at time equals 80. How do you find the velocity at time equals 80? You know the displacement value, the displacement covered in the first 80 seconds. You have time and the value of displacement. Let me just write that down. And acceleration is constant, right? They tell us in the question that acceleration is constant for the first 80 seconds. That means we can use constant acceleration formulas if we want. So for the first 80 seconds, we know that time equals 80 and displacement equals 400. What else do we know? We know the initial velocity because it started from a velocity of 0. It started from rest. We know 0. What do we have to find out? We have to find out velocity at time equals 80. So we're looking for the final velocity. How can you find that? Which equation connects these four things? S, U, V, and T. I think it's this one. S equals U plus V over 2 times T. That's the equation that connects these four quantities. Just input values in this. S equals 400, U is 0, V is what you have to find out, divided by 2 multiplied by time is 80. And that will give you a value for V. What do we get? What's the value of V that we get from this?
10.
10. 10 meters per second, that's the value of V that we were looking for. That means this point here is going to be 10. Okay, now it was not necessary to mark that point in the previous part. For drawing a graph or sketching a graph, you just need the information that you already have until that point. But now that you know the value of V at that point, you can represent that here on the graph as well. This point was supposed to be 10. Now it says find the total distance for the journey. How do you find the total distance for the journey?
Area
Anyone?
under the graph.
Area under the graph? Area under which graph?
Velocity time.
Velocity time graph, right? So velocity time graph's area gives you the total distance. You just find this area. It's a trapezium. You can just find the area of this trapezium. How do you do that? Total distance. That's the area of the trapezium. Half into sum of parallel sides. One side is 600 plus BC 80 to 560. What's that length? That is 480. Multiplied by height, that is 10. That's going to give you the total distance traveled. What's that number? What do you get from this? Anyone?
5,400.
5,400. So the total distance traveled is 5,400 meters. That's the total distance traveled. What else are we looking for? Part 4. Find the acceleration of the car for a time between 0 and 80. So we need to find acceleration from 0 to 80. We know that's constant acceleration, right? So all we have to do is from 0 to 80 seconds. Again, you can use the formula because the acceleration is constant. You know everything in the first part of the journey now. You know u is 0. You know v is 10. You know that displacement was 80, and you also knew the time. No, displacement was not 80. Time was 80. What else? Displacement was 400. So you have all of this information. You can use this information to figure out the value of acceleration. Which equation can we use? We can use v equals u plus 80. And that gives us 10 equal to 0 plus a into 80. And that's going to give you 10 over 80, which is 0.125.
125.
0.125 meters per second square. That's the acceleration in the first part of the journey. Make sense?
Yes, sir.
All right, so that was a very simple example. The second, third, and fourth parts. The first part was maybe slightly tricky, which you had to draw, sketch that velocity time graph, and that's how you would approach it. That's it for today. If you have any quick questions, let me know. Otherwise, we will end this here, and I'll see you again on Tuesday. And I expect you to do the first 2 rows of questions before Tuesday. Okay? Especially question number 27. Any questions, anyone? Any problems?
Sir,
Yes.
I have questions regarding forces and equilibrium.
Just give me a minute. Okay, so you have questions on forces and equilibrium. We can do them at the end. Once you're done with the whole syllabus, we can discuss any previous questions at that point. Okay. Or what you can also do is, how many questions do you have?
3.
3 questions. Okay. So what you can do is you can post them on the WhatsApp group along with your working. Okay. And I can tell you where exactly. So are you stuck at one particular point there in the working, or you just don't understand the question at all?
Not able to figure out what to do in the mostly in one part. That's the last part.
Okay, just post those questions on the WhatsApp group and I'll respond to that. I'll give you a hint. You can try them then, and then we can discuss them where you're stuck after that. Okay. Just post them on the WhatsApp group and we will discuss them.
Okay, sir.
All right, everyone. See you again in the next class. Allah Hafiz.